Before we get into the show, I wanted to put out a hiring call. I'm looking for my next software engineering apprentice, a young .NET programmer to help me directly with my work, building architectural prototypes, figuring out new patterns, tons of coding. And I'm looking for a .NET programmer whose hobby is also programming. For the right person, programming isn't work, it's play. And besides a job, I can guarantee that you will learn faster than you ever have before. And I will invest in your professional education and we'll work together and you will grow. You'll report directly to me. So if any of this sounds interesting to you, just send me an email or give me a call. Now, let's get into our show. Containerization in Linux with Richard Lander.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software engineering and consulting company that serves companies with mission-critical software projects, whether it's delivering the project or being an outside third-party inspector. When a project is too important to fail, you can count on them. ClearMeasure.com. A quick announcement. We're in our second year of my architect forums. You can sign up for those and on the website. And if you lead a software team and you're looking to collaborate with other peer architect leaders, just sign up at the link also in the show notes. And we recognize there's plenty of educational information for developers out there on the web freely for it, but not so much for people who are leading teams of developers. So this is a peer group aimed at that. And for those who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. My returning guest on the show today, back from way back last time, show 148, is Richard Lander, and he's a principal program manager on the .NET team at Microsoft. He's been with Microsoft since 2000, and he's been working on .NET since the beginning, since 2003. And currently he's working on runtime features, Docker container experience, blogging, and customer engagement. And he's also part of the design team that defines new .NET runtime capabilities and features. So Richard, welcome back to the show. How are you, sir?
Good. It's great to be back. A lot has changed since I was last on the show. Lots remained the same. It'd be great to kind of talk about both of those things, I guess.
Yeah. Well, for a long time, you've been working on the side of .NET that, I don't know, maybe I would classify it as the long storied write once, run many, or run everywhere. Let's run more than just Windows. Is that a fair classification?
Yeah, I mean, that's definitely one of our missions. You know, when we started the .NET Core project, we were clearly going after cross-platform. You know, .NET has always been about portable code, even when we were, only running on 32-bit Windows, Intel-type processors. The platform still had portability as a major concern. And so we've been able to take advantage of that. And so when people want to write an app that, say, targets Linux containers, you can develop that on Windows or Mac OS or what have you. And it's a very high chance that you'll just be able to deploy that to a Linux container without any challenge or ceremony, because, the low-level concerns are mostly hidden from you, much like writing something in JavaScript or Python. Though in those platforms, it's mostly hidden from you. So your platform is very likely to be portable and just work.
Yeah, nice. And there's so much movement in the space. Was it 2 years ago now? Azure Container Apps were kind of released. And can you give us a rundown on the technologies that you would consider now, hey, stable and all the kinks are worked out and everybody should be adopting those? And then kind of give us a hint on, okay, and here's the things that you should watch because very soon you should be adopting them.
Yeah, well, I'm definitely not an expert on the Azure services. other people on my team know a lot about those.
Well, just an
The
example
only
of
with-
what's of
well,
one
the
of
only thing I'll
things.
say about that is, and most of this is probably obvious, but like, or maybe not obvious actually, but there's a bunch of Azure services that are in developer division where I work,
Mhm.
and there's a bunch of services that are homed in what we call Azure Core.
Hmm.
And we normally don't try and talk about the org chart, but I think the reason why that's somewhat important is the Azure Core services are the ones that are just like super fundamental. So Azure Container Service is in Azure Core. It's like a low level building block. You can
Mhm.
absolutely go use that and have a good time getting a raw Kubernetes experience. I mean, you can also do VMs too and like completely do it yourself, but we're probably not going to suggest that idea.
Not fun.
And then like Azure Container Apps is, or in DevDiv, we have 3 or so what we call serverless services. So they're like much higher level. So that would be Azure Container Apps, Azure App Service, and Azure Functions. And so with those services, so I kind of think of this as like the rapid application development story for cloud. And DevDiv has always been about that kind of rapid application development sort of paradigm. And so these services kind of continue on that path. And so if you don't want to worry about like all the machinery underneath, then you can do functions, or app service does what? Yeah, functions obviously does, the pure serverless function type of thing. Azure App Service does websites where you don't have to worry about VMs or anything like that. And then Azure Container Apps does give you a Kubernetes story, but you don't have to know how to deploy AKS and how to scale it. Azure Container Apps does that for you. So it's serverless in the sense that you don't have to care about the underlying VMs or Kubernetes node pools underneath it. So those are all ready to go. I don't think anyone should need to wait to use any of the services that I just mentioned. Certainly what is new is Aspire.
Okay.
Now, Aspire is intended to be another kind of rapid application development. That name is kind of passe, but I still like it actually. I think it fits just as well today as it did 20 years ago. And so Aspire is about kind of like a config as code type paradigm, where you can kind of say what it is that you want to happen. I want to use these components like a Redis, and then I want to deploy to a cloud service like Azure Container Apps. And then you can just build your app, and basically all those things happen. You can deploy all the artifacts that are generated. You don't need to learn about, Kubernetes manifests, deployment manifests versus service manifests. That's all taken care of for you. And then, you can do rapid application development.
So you just mentioned a name that probably a lot of people haven't even heard before. Now, if they were paying attention at .NET Conf, they would have heard, the vision for .NET Aspire. But I think Visual Studio Preview just dropped a few days ago with the first bits. So what is this? How would you give the quick rundown for people who haven't heard of it before, and why should they be interested?
Yeah, so I'm definitely not the absolute best person to pitch Aspire, since I don't actually even work on it. I'll just give it a very high level vantage point, because that's about the best I can do.
Sure.
Is up until now, like ASP.NET Core is really fundamentally a web service website programming model. I mean, this should be no shock to anyone. And so you are basically saying, I want to write code that responds to HTTP endpoints. I either return JSON, XML, or HTML. Pick your poison. But that's the program model has routing, all this middleware stuff, and that's really what it's about. It's like, I want to give this payload to the requester. It is not at all about deployment concerns. So once you've finished your app, you're kind of left to your own devices on how you get this application into some kind of cloud service or even on-prem service for that matter. And so Aspire is about solving that next step. How do I, as part of my development flow, and one other thing is the other thing that ASP.NET Core doesn't really solve is how do I do, Redis on my desktop and then use managed Redis in the cloud?
Mm-hmm.
How do I use local AI models and then use managed AI models in the cloud? That's like well outside of what it is intended to solve, and really, I don't think it should solve that problem. It's kind of at the wrong layer.
Okay.
And so Aspire is about solving the distance, shortening the distance between local development and the cloud, making it so that you can kind of codify more intentions, and then the tooling kind of gets all those hints and then does the right thing, and then you basically have a bundle that you can deploy with. And then one last thing on that, this is a slightly off topic that we'll discuss later, but it fits in, is unrelated to Aspire, but it fits hand in glove with Aspire, is we also added tooling into the SDK. It was in .NET 7, but it didn't really get prime time until .NET 8, is you can now build container images with the SDK. So you don't have to use Docker build, Docker files. You can just do .NET publish, and you get a container image. And so that just is another piece where it's another whole topic area that you don't necessarily have to learn about.
Mm-hmm.
So if you don't have like crazy requirements for your app, it's just like, I just want to take this app and move it to the cloud and run it on Linux.
Yeah.
Then you can just do that. And so that's just another piece that's kind of taken care of for you as part of the deployment journey.
That's right, because if you're just a regular .NET app and it's meant to just run in a generic Linux container, the Docker file is literally going to be the same for every single one of those.
It's totally a ton of boilerplate. It's not super useful.
Yeah.
And we have a bunch of inferencing in the .NET SDK now. So it knows, like, if you're targeting Alpine, like when you do .NET Publish, if you want to target Alpine, it'll pick an Alpine image. If you want to target AOT or like any other type of self-contained things, it knows you should get like a runtime depths images. So it actually has quite a bit of heuristic smarts in it, so that that are really oriented on getting you both the correct asset and the most optimal asset. Because we ship like a ton of container images for like all these different use cases.
Yeah. Well, just so we can hone in on your perspective, you work within a massive group that's doing so many things. What are you laser focused on, and what do you spend the days using all your brain power thinking about?
Yeah, all the brain power. I mean, I think you mostly covered it in the intro, but I'll obviously repeat it. So the last couple years, I'll say what I've been focused on, because it's mostly just continuing. I've been focusing on a few things. One is I've been working on the both user experience and the actual fundamentals of our container offering. So most recently, we've been working a ton with Canonical, and so we have these chiseled images. So the two ways to make container images smaller are make it so that the app platform can be smaller, and then the other one is to reduce the size of the Linux footprint.
Mm-hmm.
So chiseled images are about the second part. So we removed 100 megabytes of size from our regular Ubuntu images with our chiseled Ubuntu images. And then obviously, if you want to use AOT, then that reduces the app platform size as well. So been working on projects like that just to make container images smaller and smaller, and we're kind of continuing on that path. The work that we've done today has been dramatic, so we clearly aren't going to deliver those kind of percent improvements again. just because we're going to like start to go negative.
Mhm.
But we're going to continue to refine what we've done. Another one is, I've continued to work on relatively small but important ease of use improvements in the CLI. So, a perfect example is we have. I hesitate to even talk about these because they both cause me pain to talk about, and they cause people pain to hear about. But we have these things that we called RIDs. This is like the -R thing on the command line in the CLI, and then you have to put this like weird string with just like Linux -x64.
Okay.
And we had like even way worse ones.
And can you mention
So I
what
did
RIDS stands for? Is that an acronym?
it stands for runtime ID.
Okay.
And all it means is we need a way, a currency for you to basically describe what it is you're trying to target, because we have native code in our platform, like every other dev platform.
Mhm.
And so we need to give you the right assets that'll work in the place. Like,
Yeah.
even Python and JavaScript, they have native assets. The runtimes are built with native code. So you can't take a V8 or a Node.js that's intended for like Windows x64 and run it
Mhm.
on Linux ARM64. Like,
Yeah.
totally won't work. So I have hated these runtimes, runtime IDs with an absolute passion. And so we did a couple different projects to remove that complexity from the developer experience.
Mhm.
So just one of them was we came up with this two new arguments, -A, meaning architecture, and -OS, meaning operating system. And then you can separate those as two much more kind of discernible concepts
Mhm.
that you don't have to teach people about. And then underneath the covers, we'll kind of do the right thing to make our system work. And if you want to learn about that, you can, but hopefully most people don't. We did some other projects like that, but we're trying to remove the complexity and the ceremony and the mystery around some of our product. Because when we started, it was this absolute race to kind of, hesitate to use the word death march, but so I'm using the word race, but
Mhm.
it was kind of
Weekends,
like
long
that.
nights. I get it.
Yeah, so we had two different problems. One is we didn't have a lot of time for like .NET Core 1.0, and we didn't entirely understand what it was we were doing.
Mhm.
Like the project was just such a dramatic departure from what we were doing. And so over the years, we've kind of been resolving some of the sins of the past.
Mhm.
This RIDS one is totally an example of that, where we didn't get it right. So I focus on things like that. And then the last one is I do a ton of blogging. So like last year, we did a Y.NET post that really tried to explain what the most fundamental value of the platform was, what it is we tried to deliver, and that you could readily compare and contrast with other ecosystems. Um, and done other. And then I started this Convenience of .NET series last year as well. There'll be more posts on that series. Again, trying to really talk about uh, what it is that the platform delivers, because
Mhm.
so much of the blogging is about like, oh, we delivered either this new feature or this improvement to this existing feature, and then it's up to the reader to like do the sum of like all these blog posts, and it's like, okay, well, what's the value prop altogether? And we didn't have much content
Yeah.
that described that, so I really took that on to myself of like, okay, I want to do these broad pieces where the readers can much more readily understand what the whole value proposition of the platform is. So that's what I work on, those kinds of things.
Okay. And every bit of this is what the core of how a .NET application runs inside of a Linux container, right? Like your world is containers.
Yeah, I mean, I wouldn't say it's like 100%, but because I work on some other things. So, like another project that I've been working on is our WASI, which I'll explain in a sec, our WASI story. So, but it ends up being like super, super similar.
Mm-hmm.
So we have WebAssembly, WASM, and that's only been in browser land for the most
Yeah.
part until this point. And then the WASM people said, hey, we don't just need to run in a browser. It'd be awesome if we could run in other places. And I think at least some of the people in WASM land had previous Linux container
Mm-hmm.
experience. And so they said, oh, these two, we can make WASM live in that same domain. And containers are awesome, but they do have some problems with them. One is they're definitely not portable. So, like a container image either works on Linux x64 or works on Linux ARM64.
Mm-hmm.
I mean, taking emulation out of the discussion, that means you have to target one or another intentionally. And then you basically have to like carry quite a bit of user mode Linux around with you. So they tend to be larger. They have to be updated relatively frequently. And so it's, we could potentially solve some of those problems with WASM, but then WASM doesn't have an API is the problem. WASM is basically like an ARM or Intel chip or RISC-V or something. So it doesn't do anything, is a challenge. So WASI is a WebAssembly system interface. And so it's like, okay, how could we make a whole API system so that we could expose some low-level functionality. So these are like file systems, HTTP clocks,
Mm-hmm.
things like that, key value stores. How could we expose stuff like that, and also let other people, like random developers, expose their own interfaces, and then make that all into a system? So that's what WASI is. And so I've been working a little bit on that. I posted a blog post on it late last year. But it all ends up being all the same stuff as what I've been working on. It's just different flavor of, mostly the same thing.
Yeah, I can kind of see some of the listeners, their eyes are glazing over and like, what is all this stuff? I just want to write my code. I just want to throw it up to Azure and say, hey, run my stuff. Or I want to throw it at a smartphone or a desktop computer. I just want it to work. And all this is like the flavor of how to make it so developers actually don't care about everything that you just said.
Yeah, 100%. So my world is all about the details, and about these kind of fundamental systems. And so back to the example I gave earlier, which is, .NET Publish now produces container images, Linux container images, so that you don't have to know Docker files or how like the command line on .NET, Docker build. Just use .NET Publish using, the normal approach. Well, that is what we'll eventually deliver for WASM as well. In fact, this is the funny thing. The primary format, so Docker Containers has a spec called OCI, Open Container Initiative, I think is what it stands for. So it has a spec. And so when you do Docker build, it produces a compliant OCI image. Well, it turns out that the official way of distributing WASM code is through an OCI image. So it literally, we will be able to use the exact same .NET Publish mechanism, probably without basically almost any changes at all. And so you'll just use slightly different .NET Publish command line parameters. We'll build the WASI underneath the covers for you. We'll produce an OCI image. We'll use exactly the same flow. And then, that could even work with Aspire. You could say, oh, like this particular function or service or whatever, please build that as WASI. Please deploy this to this WASI host, and it'll all just work. And it will literally, you won't even have to have really touched anything that's very WebAssembly or WASI oriented. It's just all covered for you. But obviously, the reason I'm talking about these things is, well, I hope someone's interested, but also hopefully this demonstrates, like, that we're continuing to focus on emergent technologies, and that there are people on the team that you think are sorting through all these details so that you mostly don't have to care.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Well, you haven't touched on it yet. I know you've written extensively on and presented on the chiseled containers initiative. You mentioned, reducing it by 100 megabytes. Am I overstating it, or is the WASI version of the container just like a pathway to yet another reduction in image size and complexity?
So the WASI one probably will be smaller again. It won't remove 100 megabytes because we don't have 100 megabytes left to remove.
How big are we at this point? What's the expected size?
I can answer that question. So, if you build a chiseled image, with AOT, so compressed, it will be under 10 megabytes. That's everything all up. So that's huge. I mean, when we first started,
by huge you mean small.
yeah, huge we mean small. Yes, huge. It's like revolutionary compared to where we started. I think when we started with containers in like .NET Core 1.0, the smallest app, like Hello World, was like 150 or 200 megabytes. And that was also a reflection, like the base images, Linux base images, have progressively gotten smaller over that same time frame. So everyone's kind of been on their own size journey. The chiseled thing and our AOT initiatives are a big step function on what has been naturally occurring. You can definitely produce, 10 megabyte or less container images. We're talking about compressed, because container images have this kind of weird duality of compressed and uncompressed. When they're in the registry, they're compressed. When they're on your disk, they're uncompressed. They're being pulled over the wire, they're compressed. When they're on the container host, they're uncompressed, just like they are on your developer machine. And really the metric that really matters is compressed, because in the cloud, people don't really realize this, but there are caches there, but when it matters, there isn't your image isn't cached. Because with the cloud, you're renting someone else's hardware, and they give you fresh. Thankfully, they give you fresh VMs and that kind of thing. And so then you're pulling these compressed bytes over the wire, and you want that to go as fast as possible so that your app can load and then start serving requests with, JSON or HTML responses. And so, compressed is the number that matters.
Well, I know you and your team geek out on the reduction and how to make these things possible. But from my perspective, what's the most exciting part about it is not, we're going to save storage. And of course, everyone, storage is cheap, yada, yada. But it's not storage. It's IO, like you just mentioned, and not just transferring over the wire. Okay, recycle a new version of the service, and how fast can it, quote, reboot, because it's actually redeploying from the image. But in automated builds, in testing, in test environment deployments, all of those activities in a fully automated DevOps environment, even before it's in production, that's just a ton of IO. It's a ton of file copying all the time.
Yeah, 100% right. If we want to, greenify the planet, let's reduce the number of bytes that we're transferring over through these networks all the time. So yeah, we've been totally focused on reducing that and helping customers move to these smaller image types. So one of the things that we did in late last year, we finally were able to GA these chiseled images. They'd kind of been non-GA for about a year.
Mm-hmm.
And so customers, like, they had been hearing the message. There's no question, because we were getting a lot of feedback and interaction. And so on one hand, people were saying like, oh, thank goodness, I'm totally gonna deploy this now. And people did that. That was about 50%. The other 50% was, love this, but one major problem. So the issue is to make the images small, we removed this library called ICU.
Mm-hmm.
ICU is the Linux globalization library. So it's the thing that knows about all the languages in the world.
Yeah.
It also knows about calendars and currency symbols and that kind of thing. And so I'm like completely making numbers up, but like something like, between 25 and 50% of apps don't care about that stuff. And now I'm talking about server apps. And then the rest definitely do. So we made a chiseled image. They're called extra, is the tag that we use, chiseled extra images. And these include TZ data and ICU. And so we, went to the extra effort of producing yet another container variant. We have like 200 different variants to solve a whole bunch of different needs. And so then those customers can move to chiseled. They have ICU and TZ data there. TZ data is time zone, by the way, all the time zone information in the world. So you can ask the question of like, what is the time zone difference between, say, like Austin and Seattle? You can ask that question. But if TZ data isn't present, you can't get that answer.
Right.
In fact, it'll probably get an exception. So we produced those images, and then the other half of people were satisfied. So then they can move to a much smaller variant and be pushing less bytes across these networks.
Yeah. There's certainly the server-side Azure story, which is huge because we need tons of software that's just cranking away, doing stuff in the background, moving data, serving web services. But one guest we had on the show recently talked about the explosion of the IoT industry, and that is already on a path faster than the mobile revolution. And so if we think we have software that's running on our phones and on tablets, and then software that's running on little tiny computers running around everywhere. You've done tons of demos with running on a Raspberry Pi, but what does the next generation look like for having some code running on the edge? Or if I say, I want to be a totally cloud company, but it'd be really convenient if we could stick a micro server up next to the network rack and just have a little tiny server that's right here doing something. What's that vision?
Yeah. So, it depends what it is you're looking for. So, so .NET totally runs on the Raspberry Pi. We've been kind of working on that since the Raspberry Pi 2
days. Now we're to Raspberry Pi 5, I think.
Yeah. I actually have a Raspberry Pi 5. I haven't actually opened it yet. I have a box beside me that I think arrived a week or two ago.
Well, those finally require a real heatsink. I know. I learned that the hard way. Don't run it without the heatsink.
Yeah, I'm working on some stuff right now, I won't get into, but after that's done, I actually intend to do some another Raspberry Pi project, which I'll then blog about and share. But anyway, so support the Raspberry Pi. We don't support the Raspberry Pico. series.
Okay, the small one.
Pico, yeah. Those are the super small ones. Those look super interesting. And then anything smaller than that. And so one of the things we found is that so if you wanted to build like let's see, I'm trying to think of a device that I have in my house. Like if you wanted to build what's the thing in the house connected to the furnace that controls the
Thermostat?
temperature? Thermostat, yes. If you wanted to build a thermostat, the Raspberry Pi is clearly too big. The Pico itself might be too big. Pico, whatever, might be too big as well. So you're getting pretty small. And so we don't really have very many customers coming to us for that. Although I should say there is a project, the Nano-framework, that I should plug. They actually do serve industrial customers, and they're focused on like ESP32 and that kind of thing. So if you're into ESP32, and we do work with them in our IoT project. So if you want ESP32 form factor is the right size, then there is a solution for that. But the thing that we found is there have been some customers who have come to us and said like, oh, we totally want to do this edge deployment thing. Invariably, the thing that they're talking about is bigger than the Raspberry Pi.
They just need a remote rugged server. Huh?
Yeah, it's a rugged server or edge to them. So we have had some people with cars. Those tend to be bigger than Raspberry Pi. Like if you think about the car that's in like a Tesla or a Rivian or something like that, those are bigger than Raspberry Pi, and they have GPUs in them and that kind of thing. Or in the factory scenario, they tend to deploy things bigger than Raspberry Pis.
Oh yeah.
So just from the customers who typically would turn to Microsoft for a solution, we definitely have had some in the more Raspberry Pi form factor space, but still the vast majority of people, even in Edge, are deploying compute that is bigger than that. That's not in any way a critique of Raspberry Pi form factor. I love it.
Sure.
I'm just saying from a just pure commercial standpoint, we still see people deploying bigger gear than that, even for Edge.
Well, I'm thinking, and I have a Raspberry Pi rack, on the network. And,
awesome.
And it's running Portainer, and it's running the commodity stuff like my own Pi-hole DNS filter for the kids and all that.
Pi-hole.
And it's great. But even regardless of the size of the edge server, I guess in the term, I'm thinking of density. I'm thinking of, okay, how many little things can I put, on one device, even if it is something like an Intel NUC sized, computer.
Totally.
It's just, okay, can I have one device in that regional office that has all of the parts of a distributed system where part of it needs to be at the node level or at the regional office? Or think, 7-Eleven convenience stores where it's like, okay, I need to have something running at each of the stores, transferring data and doing some things, but I want to minimize my hardware throughput. So I would love to have density so that I can have one computer that I'm supporting that just has all of my kind of containers that are running.
Yeah. I mean, .NET will totally run there. So one of the things we found, even from the Raspberry Pi 2.0 or Raspberry Pi 2 days, which we totally hadn't even really optimized for, is the SDK. So DevFlow was, at least in those timeframes, unbearably slow. But apps ran super fast. Apps had, because there's so much code that's being run in the SDK. So our performance story for actual apps, all the way back to, that's like almost 10 years ago, has been great. So we haven't really had a performance challenge there. And also, if you run, so since Raspberry Pi 3, I believe, it's actually been a 64-bit chip on the Raspberry Pi, but they, were stayed with 32-bit operating system for quite some time. Now the 64-bit Raspberry Pi OS has GA'd, and so you can install that. And literally 100% of our optimization effort for ARM is in ARM64. So if you're running .NET code on a Raspberry Pi, you should absolutely run the 64-bit Raspberry Pi OS, and then you'll get the benefit of multiple years of performance optimization from my team. If you're running on 32-bit, then you kind of you're not getting nearly as much benefit. I mean, you still get like half of Stephen Tobe's blog posts from performance, but from anything related to the JIT, so CodeGen, that is all 100% oriented on, and all the SIMD stuff as well. That's all 64-bit, and it will run fast. But like back to your 7-Eleven example, so we do talk to customers like that. I'm not sure 7-Eleven in particular. Yeah, but so they're increasingly running like Kubernetes clusters in stores. Certainly big companies like Walmart and Target and those kinds of things. I'm not saying I'm talking to those particular companies. Right. But those that are class like the scale of example. And so possibly some of them have chosen Raspberry Pi as their compute form factor. Maybe they're choosing something else. But if you can figure out how to get the right density of node pools inside with Raspberry Pi, have at it. .NET apps will totally run there. Yeah, but I definitely run 64-bit.
Oh, sure. Yeah, and I don't think people are throwing up Raspberry Pis as corporate servers, because Dell and HP do a good job of having one U small servers. But this smaller container size and the density, that the part that I'm excited about is the headroom that we have before we get to the point where we say, I don't just need one server. Now I need a rack of servers.
Yeah.
And now I need cooling. And now I need, this closet is the loud closet.
Yeah. I mean, in all those scenarios, you can use our stuff. We've done the work, and you're right. If containers are your unit of deployment, then the chiseled images are absolutely going to help on, something as small as a Pi.
Yeah. Awesome. Well, before we go, since, you are inside Microsoft, you write code all day. This is not your area, but I just want to get your opinion, because Microsoft, there's been the splash, new version of Windows 11, and everybody's seeing the announcement of Dev Drive, and for Visual Studio applications, and so I was just curious, is there a story inside Microsoft among you and your peers that are like, have you been using Dev Drive or something like it for a long time for your working copies, or is that something that was like, okay, hey, it just came out, but they're working on some stuff and maybe wait and see?
Yeah. So that's more of a Scott Hanselman question. I am not very embedded in the Windows ecosystem. So I literally have, so on my desk right now, I have one monitor, and then I have like a IO Gear KVM switch thingy. Yep. And so it connects to a couple different machines. One is, the primary machine is a Ubuntu 2310 x64 machine. That's my main machine that I use as much as possible. It's not connected to the corporate network. Okay. So I just, if it's something related to the .NET org, then I just use that. Yeah. But so it doesn't have Teams and email on it. And then when I need to actually talk to my people, I press the other button, and then that's an ARM64 Windows box. I can't even remember. Oh yeah, Volterra. It's a Volterra machine. And so I only use that when for Teams and email and that kind of thing. And when I don't need to talk to my coworkers, I switch to the other one, and it's just like focus mode. It's all Linux. So that I'm mostly on Linux. So I don't use Dev Drive. I've never enabled it because I mostly don't do development on my Windows machine. I just do everything on Linux, because
you're dog fooding.
As we kind of have covered to this point, I'm primarily focused on Linux.
Yeah.
We have other people on the team that are primarily focused on Windows, and I love them for that. But that's not me. I'm Linux, so I'm going to use Windows as little as possible, because that's not what I'm charged. That's not what my role is. My role is Linux, so I should be fully immersed in the ecosystem. So I'm typing, apt commands all day long.
That makes total sense.
All the things. JQ.
So you're on Linux, Ubuntu desktop on Linux.
Yeah, Ubuntu desktop. Yeah, I do. I've spent a fair bit of time on Manjaro as well. So that's in the Arch ecosystem to kind of get that flavor of things. So, when I do that stuff, I get .NET either through the Manjaro package manager or through the Arch user repository. So I really try and learn what that experience is all about and try to figure out what's good and what's bad about using .NET in those places, including VS Code. So I'm using C# Dev Kit in all those places and trying to validate that experience. So that's what I do. So no dev drive for me.
Right. So you're in VS Code on Linux all day, or do you also have JetBrains Writer?
I don't have JetBrains Writer.
Okay.
I really like VS Code. By the way, I do have a MacBook. My laptop is a MacBook Air. It's the first generation of Apple Silicon.
Mm-hmm.
That's been pretty good. So I use that a fair bit. But when I'm sitting at my desk at home, it's mostly Linux. If I go to work a couple of days a week to the office, and then I just bring that laptop and work on that.
Yeah. Well, very cool. Well, that's hey, you're all in. You're dog fooding everything that you're building. Totally immersed. Yeah. That's great.
Yeah, totally. Someone's got to do that.
Exactly. Well, we thank you for your work. I mean, just getting the container image sizes down and getting to the point where the container image is the normal way to publish a server side .NET application and making it seamless. I mean, that's huge because that's not always been that way.
Yeah, I mean, we've obviously been working on improving it over time, but I think the SDK publishing thing is really the kind of massive step function change in user experience. And just a super quick vignette on that. The funny thing about that is how that happened is in .NET 7, we added tar support into the platform, which we'd never had before.
More than just zip.
We had deflate and zip APIs for a long time. And then someone on the team realized, tar is literally the last building block that would be necessary in terms of having a built-in OCI image solution. Because container images, people might not realize this, they're just tar.gz files built a particular way. So they're basically like NuGet packages, except they're tar.gz. So that was the last piece in the platform that was required. And so all that code could be written in C# without having to do a process run to some tar command. So that's how that whole thing came about.
That's cool. Now, I didn't know that. I know we could rename a NuGet file to .zip and just open it. Are you saying the container image, we can rename it to .tar.gz and just open it?
Well, a rename is kind of slightly the wrong way to put it because it's not present on your disk in the same way that a NuGet package is. It's owned by the Docker daemon in your machine. So there's a command on Docker to export a container image to your local disk. And then it would be a tar.gz file, and then you would be able to open it with tar.gz Explorer tool.
That's right. So, it's really just the definition file that we have for the image.
No, it's there. I think so the Docker daemon is also on your machine, but it's an abstraction over all that storage. So you don't see it. Like when you type docker pull, it doesn't pull, foo container.tar.gz into your downloads directory. it's hidden that from you, so you don't get to see that. The NuGet one is supposed to kind of be abstracted, but it's just one level less abstracted, because it's like, oh, I'll just go into my .NuGet folder and I can like go through this directory hierarchy, and it has both the NuGet package there and the exploded form. Or you can obviously download a NuGet package off of
NuGet.org,
or what have you. So main point is that the actual file is more hidden from you, but there's a Docker CLI command to get it, and then you can do the thing. Also, with you might not know this, with the SDK feature, you can do 3 different things. You can publish. You can publish. The default is publish the built image to your local Docker daemon. So you build this thing called app, if that's what your app is called, and you'll after you've typed .NET publish, if you type Docker images, you'll see an image called app, and it's like, that's the one I just built like 2 seconds ago. That's the default. You can opt to push to a registry. You can push to Docker Hub, you can push to your ACR, you can push to an Amazon registry, wherever you want. And then the last one is you can just drop a tar.gz to your local machine, and then you can do whatever it is you want to do with the tar.gz. You can import that into your local Docker daemon, or you can push that to the registry, whatever you want to do with the tar.gz. So that's an easy way to get a tar.gz file.
Nice. I did not know that. So that's awesome.
Yeah.
I'm sure there's plenty of listeners out there as well that are happy to hear that rundown.
Yeah, that was a late addition.
Okay.
Yeah.
So we got the preview version of Visual Studio that's out there that has this new stuff, or how much of this stuff is like old in GA and .NET 8, and how much of it is in preview status?
That I've just discussed.
Yeah, the publishing directly to
that's all. Well, I mean, it started in .NET 7.
Okay, but it's totally GA and .NET 8.
Yeah, and we just published. We just shipped .NET 8 80200 SDK, and there were some more fixes, significant fixes to all this stuff in 80200. So that came out like a week ago. So I'd recommend ensuring that you're using 80200. If you're using Visual Studio, you would have been automatically updated to it.
Yeah.
By now. So we'll continue to invest in that. Mostly these are just like UX convenience type things, as opposed to like, massive changes. But you can expect more little convenience things to make your life better.
Totally. Well, I'm just thinking of the automated DevOps chain and the command lines to publish, and let me containerize what I just published using the Docker file, and let me put it up to the Azure Container Registry. Now it's like this chain of command lines that can go away because now I just modify my .NET publish.
Yep, that's the intent.
That's perfect. Okay. All right, so listeners, 8.0.200. That's the one that I just downloaded.
Yeah, past that should all be good.
All right, cool. And that was just what, February 13th or something, just about a week ago.
Yeah,
that's great.
Yeah, and just to be clear, the what we shipped to GA is also fine. I think of the 8.0 release for the container publishing as being where it got good, and then it's just minor improvements after this.
Perfect. Yeah, perfect. Well, thanks so much for coming on the show and giving us the latest in container development for .NET. I appreciate it.
No problem. Glad to do it.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.